Hello everyone, my name is Tan Meng and this is my SIF 1006 experiments recap. Throughout the whole course, I have done 5 experiments. First is DC1, measuring the internal resistance and the precision of the galvanometer. Second is AC2, determination of impedance of inductor and capacitor using an oscilloscope. Third is O2, refraction of light. Fourth is M2, rigidity modulus of wire by using Maxwell needle method. 5 is M1 tension and kinetic friction. The first experiment is direct current 1, measuring the internal resistance and precision of galvanometer. And these are the apparatus, measurement tool and objective of this experiment. For introduction, this experiment aimed to obtain the internal resistance of galvanometer which cannot be measured directly. The experiment relies on the concept of potential divider and the formula used is as below. Part A of this experiment is to determine the internal resistance of a galvanometer. Part B, determination of the precision of galvanometer. Part C and Part D is determination of an unknown resistor R. In Part C, the voltmeter is parallel to both unknown resistor and ammeter. In Part D, the voltmeter is parallel to the unknown resistor only. Throughout the whole experiment, I have obtained the internal resistance of the galvanometer. I've obtained sensitivity of galvanometer. I've also obtained the actual resistance of the unknown resistor. I found out that determination of R with voltmeter connected parallel with the resistor only, which is part D, is produce more accurate result than part C. The second experiment is alternating current 2, determination of impedance and of inductor and capacitor using an oscilloscope. And these are the apparatus, measurement tool and objective in this experiment. For introduction, this experiment relies on the concept of AC circuit. Alternating current is an electrical current that regularly reverses direction and changes its value constantly with time. These are the relationship between voltage and currents that across various kind of electrical component in AC circuit. And below is the formula to calculate the reactance of 3 types of electrical component. The analysis of the reactance of the component is done through phasor diagram. In a phasor diagram, the phasors are represented by open arrows which rotate counterclockwise with an angular frequency of omega about the origin. The resultant of 2 voltages with a phase difference is calculated as the formula. For methodology, the circuit is arranged as below, where the resistor and inductor are connected in parallel. The potential difference across R, L, and RL is measured using oscilloscope. Repeat the measurement, calculated the impedance of the inductor, repeat the above step by replacing inductor with capacitor, calculated the capacitance of capacitor using the following equation. In conclusion, these two are the result obtained from the experiment. The inductance of the inductor has shown a significant amount of error from the given value, but the capacitance of the capacitor shows low error and uncertainty. And third experiment is mechanics 2, rigidity of modulus of wire by using Maxwell needle method. And these are the measurement tool, apparatus and objective of this experiment. For the introduction, this experiment exploit the idea of modulus of rigidity. Modulus rigidity is a measure of elastic shear stiffness of a material and is defined as the ratio of shear stress to the shear strain. The modulus of rigidity is concerned with the deformation of a solid when it experiences a force parallel to one of its surfaces, while its opposite face experiences an opposing force. For the experiment method, the experiment is conducted by arranging the apparatus as follows. The Maxwell needle is then twisted to induce oscillatory motion like a torsional pendulum. The period of 10 oscillation is then recorded. Repeat the experiment with solid cylinder in the inner side of the needle. The data were analyzed by using linear regression with the following formula. In conclusion, the modulus of rigidity of the wire is 71 plus or minus 4 gigapascal. By considering materials with modulus of rigidity within the 3 standard deviation from the mean, the potential type of the material of the wire is this. The fourth experiment is optics 2, refraction of light, and these are the apparatus and objective of this experiment. As for introduction, this experiment exploit the idea of refraction. Refraction occurs when light passes from one medium to another, causing a change in its speed and direction due to differing the refractive indices. The relationship is governed by Snell's law. This experiment is conducted by relying on this mechanics where the light undergoes refraction twice across the prism. These are the formula needed to use to calculate the necessary quantity in this experiment. In part 1 of this experiment, we need to align the prism with its pointy head facing the collimator. Then we need to measure the angle of the refracted light from the center, both sides, to obtain the angle of the prism. In part 2, we need to measure the angle of the straight position of the sodium light, and then we need to rotate the table until the refracted light stop moving and reverse its direction. Then we measure the angle of its refracted light. These are the results I obtained for these experiments. The last experiment is mechanics 1, tension and kinetic friction, and these are the measurement tool and apparatus and objective for this experiment. This experiment relies on the idea of kinetic friction. Kinetic friction is a force that acts in the opposite direction to the motion of an object. It is directly proportional to the normal force exerted by the surface on the object. The free body diagram for the body experiencing kinetic friction when moving is as follows. The analysis of data in this experiment is done by using Euler's Capstan equation. For experimental method, first set up the apparatus as the picture. Second, record the reading of the balance for angle of wrapping of string along the circular segment from 0 degree to 360 degrees. Repeat above step with angle 360 degree to 720 degree. Analyze the data by using the below equation and perform linear regression. These are the results I obtained from this experiment. So, in summary, throughout this course, I have learned how to first do error analysis, second, use programming language to aid my data analysis, third, you do measurement precisely, and last, take account on the source of error. Finally, thank you everyone for watching.